See, after running the simulation, there will be some PDB file. Check in your output folder whether you have PDBs. And open, you can load this PDB file in the BMD. You load this PDB file in BMD. All of one file. First one. The first one is the file which was created by this story. अच्छा अभी पे इंस्टॉल हो रहा है you run the have you run total simulation input load how many there is some error total charge in the system so check your error so this is the error on oxygen the charge is minus we have the PDF file. Okay, BMD files. Yes, BMD. You upload the PDB on the BMD. Just drag and drop. Drag and drop. Application at least. Otherwise, there will be some reason. Oxygen is minus. Now you. This is the initial configuration. The file which was generated by Tony at t equal to 0 and now you load the last one. Okay, now this has some changes. Now I will say this. No, not this one, the first one. This is the last one. Yes, this is the last. So you have to run for at least 10,000, 15,000 cycles. Then only you will get the density. You have to run the simulation for at least 10,000, 15,000 cycles. Right now the option is 100. Then only you will get the correct density. See, if you have any question in input file and force field file, you can. Otherwise, you try the second one. Now you take a single box. To take two components, one is water and ethanol. So for water, you have the force field file. Now you make the force field file for the ethanol, and then change the Tony underscore input file and run the simulation. Done. So for ethanol, you need force field parameters. So you note down this force field parameters. So this is the force field parameters for ethanol, and accordingly you have to make the force field file. See, you can understand this meaning, CS3 CS2OH, CS3 CS2H, sigma epsilon. Then second one is bond parameters, bond length, K and R naught, then K theta and theta. Then we have the dihedral term. In the case of ethanol, we have the dihedral term. So also note down these things. For dihedral, we need 4 atoms. To use all this information, make Tohi underscore FF underscore OPLS for ethanol. In the same file, Tohi underscore FF SPC, you change, make all the changes. Also, you put this also. You rename it as another file. For each molecule, make a different force field file. Got it? Right. See, the question is, so note down the question. So point number 2, a single box, two components and are water and ethanol. Use the NPT in symbol. Use SPC for water and OPLS AA for ethanol. Correct. And for OPLS, these are the force field. These are the force field. In input file, we have to make some changes at some places because we have two atoms, two different molecules. So that we will discuss later. First, you have to make this force field. Then again, we will go in the input file one by one, and we will see where we can make the changes. OPLS. So you can write Tohi underscore FF underscore OPLS. See, one important thing. In the Tohi force field, all the energy term, right, kilocalorie per mole is in Kelvin. So first we have done changes we have done. In the second, which is the bond, the coefficients are in kilocalorie per mole. So we have to again change all the parameters. The Kelvin, right? Again the third one, kilocalorie per mole, right? Fourth one is in kilocalorie per mole. So you have to change everything into Kelvin. Yes. So you know type every information in the Excel sheet. Then you do all the calculations. Then make the force field. Once these two files are ready, then we can do all the remaining, tutorials. We can use the same water ethanol for 2 box. Yes, we can do 2 and 3. So note down or you take a photo of this. You have to do it right now, right? No, not 3. If you want to do, you can come in the next class. Try, but I'm not sure. See, if you can make the force field file, so we can run the simulation here. Otherwise, you have to make the force field file. So my suggestion is you make the force field file. Whatever you have done, you search for the acetic acid and the butyl acetate. See, for tutorial 4, 5, 2, 3, we can done with water ethanol. 4, 5, we need water, acetic acid, and butyl acetate. If we can make the force field file tomorrow, on Monday we can only discuss the simulation part. Otherwise, we have to make here the force field. If you can do so, we can save our time. We can give more time on the input because you have learned how to make a force field. So repeat the same process, and so that we can also discuss the some analysis part, which is the some utility program is there in the Tohi. We can use it and analyze RDM. KB, Boltzmann constant. So convert kilocalorie into joule per molecule. Then divide by Boltzmann constant. That will give you Kelvin. कोई biological system का है इसका एग्जांपल में है मिलेगा है ना हाँ एग्जांपल में जाके देखो examples are there
Nanotube is there. You can see the nanotube example. Yes. This is what biological ubiquitin, nucleic acid, peptide, small peptide. So examples are there. So you can go and find the examples. So from where you will find the force field? Any idea, like from where you can find the force field? Not source force. You on the Google. If you are interested in OPLS, so online server is there. On the Google, you type ligparsen. Ligparsen. This is only for OPLS. Only OPLS. If you are interested in, so ligparsen is for the OPLS force field. So the use is very simple. You have to upload the single molecule PDB file. You know how to make a PDB file using any software. Then make the structure of molecule using the PDB file. Upload the file here. Like for acetic acid, you draw the acetic acid. They save the PDB file. You upload the PDB file, right? Submit molecule. It will give you all the parameters. Sigma, epsilon, charge, all bonded, everything.
That will be given in that Kelvin or again
Kilocalorie.
Kilocalorie. So we have to
Convert. So universal is kilocalorie. He uses is in K. So in Excel you can make one sheet with a formula. You have to only change the values. So use this one, and you take the force field for what butyl acetate and acetic acid. So that on Monday we can only discuss the problems, how we can solve and what are the different analyses. You can try this leak project. Draw a simple ethanol. You draw ethanol. Ethanol. And upload it, submit it. It will give you the force field. Oh, yeah, no. Draw the structure, save it as PDB.
Okay.
PDB. Ethanol. So that you can change these values, whatever I have given now. You put the ethanol and you check all the force field parameters from my given value. See, in the Excel sheet, I have done the calculation, right? So here we have the kilocalorie. I have converted in the Kelvin using whatever equations we have. So make the Excel sheet so that every time you do not have to do the calculation, just copy paste the values. You can cross check for ethanol. See, this atom type, right? So this atom type is given by me. This ligparsen will give you this number. The Parsin will give you numbers. This variable you have to define. Based on what? So based on the charges. So these are the charges. So the first one is 800. It is for carbon. So I have given the variable CE, carbon for ethanol. For each molecule, this variable has to be different. If you are defining the variable for the acetic acid, so you cannot use CE. Acetic acid carbon will have a different charge. Right now, then the remaining, the 318023 all have the same charges. So it means all the atoms are same type. So I have given He. Right. So in a similar fashion, you have to define the atom types.
Yeah. ये वो एक है। अरे ये यहाँ पे एक मॉल्स में जब लोग बनाएंगे फिर आप हर स्टेप में ऑप्टिमाइज करना पड़ेगा नहीं उसको डायरेक्ट लेके मतलब पूरा मॉलिक्यूल एक बार में ऑप्टिमाइज कर लेंगे Not mall. Mall देखा नहीं टीवी भी देखो रखी
कौन सा साइड का नाम
पहला पार्ट से
Sir, we have to optimize. Not necessary. Optimization is not necessary. You just draw ethanol. Then same as PD. Do it same. Same as PD. Same as PD. Okay. Now open the lip parcel. Now open lip parcel. Yes. Now open the lip parcel. Go down. You upload. Use file. Load your PDT file. Change the location. This is your ethanol. POX. You have to draw ethanol. God is not a free software, right? If you have a license, then only you can do that. So just Google Avogadro. Avogadro is freely available. So just download Avogadro. Google Avogadro. Avogadr. Download it. Can draw.
But already it is there. You check your system, Avogadro is there. It is very easy to draw, right? You have to draw ethanol, take carbon, then take hydrogen. See, you can easily draw a molecule. Take carbon, hydrogen, oxygen. This is molecule, right? But this is not the actual ethanol, right? Now, so there is one tool here, E. E stands for the energy optimization. You just click on it, start. So this is ethanol.
Where is the energy?
Where is?
Oh,
E at the top. Just click on E, start. Nothing is required. These are the by default, something is there. Then you save. File save as downloads. You check the file PDB. So in the link margin, you just upload your file. Download ethanol. कुछ प्रॉब्लम हो गया फिर से ट्राई
स्टॉप कर
Yes.
It's not.
And the three does.
I see, I see.
मेरे को 2 बार ट्राई करके पता नहीं वो
Input file में daughter is doing
और सिग्मा क्या
3 down.
ये क्या होगा ये क्या है ठीक है ये क्या है बॉन्ड स्ट्रेचिंग ये क्या होगा बॉन्ड है 1.5 एंगस्ट्रॉम ये क्या है ये एंगल हो गया ठीक है ये सब नीचे सिर्फ टोटल पैरामीटर इसमें क्या करता है ये ऑलरेडी आगे 0 1 लिखना है 1 2 3 and last 0 it will be seen it was similar to harmonic
पहले हिसाब से बुलाना पड़ेगा
हाइड्रोजन आसिड कार्बन डाइऑक्साइड शुद्ध कुछ बोले जान सर what is it अगर मैच पूछ रहा था इन नेक्स्ट ईयर सर सिंगल पार्ट सिंगल
एक्सपेरिमेंट का अपन देखते हैं सिग्मा का देखते हैं
उल्टा नहीं
बोले कि जीरो है जीरो ठीक है एच जीरो टू हाइड्रोजन ले एरोप्लेन अंतर
हाइड्रोजन तो हमरा जीवन
सही है
Basically, this is what it's being what it in the chart needs to be.
First of all, the hydrogen, the single people that you have all the time. Okay, so, sir, again. So this is the pattern now. The one thing that you are there's a bunch of other players. Now I will tell you. See, now this frequency is not required, right? It is printing every after 10 bar. Because I have right now, so now you have to change. Where is your downloaded?
download
Yes, maybe what with the extension of dot here. See, force field coefficient. Now you have all the you have drawn then you have drawn hydrogen. So you have to remember this sequence. Whatever sequence you have used to draw the molecule, you need the parameters in that.
one hydrogen, two hydrogen.
So remember the sequence, it's the same. It will definitely that. Here it's the numbers. You will use the parameters as per the sequence. So here we have van der Waals parameters. Sigma epsilon. Epsilon will be converted to the and then you have the bond distribution parameters. This is PR, this is R, industrial, this is kilocalorie per mole, and this is part. So you have to convert it into One skill set or more. Key. Manipulation. Use KR. Manipulation was. Yeah, this is your key.
Okay.
Bring on. Yes. In Bengal, theta and theta. Then you all of the just take Gaussian parameters. Again, we have Gaussian parameters. This one first column, then this column and this one.
Okay, when for the input where we were putting one, then
See, what is this Gaussian parameter? I will discuss on Monday. Other informations.
But really clear. So obviously, if any of the doubt, but and number of non-conductor.
In this case, see, go to the chart. So the chart is this. This is second atom. This is 4. Then this is 8 and then this is 6.
Use that.
Right.
But we have to define each and every non-bonded.
Right. That you can define manual. If it is a hydrogen for ethanol, we put
Today's session, okay, let me again extend my principal to Anand Bharti for carrying out this session. So again, we will start on Monday. So tomorrow, if you have any doubts, any sections, we can discuss. There will be no teaching us. Okay. And I will share this email ID. If any doubts, you can contact me. So on Monday, this is the problems, what does us discuss, the tutorial.
So you make all the port field file at least. Then only we can discuss.
Yes, we are the first field
Port
file.
field
And
file.
only it will be quick. We done.
Otherwise,
We have to again come back and prepare the port field file. To prepare it through this region. And then they will start. Any queries, any questions? Okay, fine. We'll stop here.
okay.